I say there's 3 takeaways that I would give any developers. It's, user input number 1, number 2 is user input, number 3, user input. Do not trust user input at any case. And I think we haven't even talked about AI yet, but I will kind of drop the bomb and I would say it's not even user input at this stage. Now it's all the way to like LLM outputs and what the model or agent says. That's like a whole different paradigm to get developers to think in that regard.
Aren't LLMs supposed to produce good code or secure code?
Yeah, I mean, I wish. If you're bringing a coding agent to an existing code base, what happens, like what do you expect to happen if the code base is already riddled with vulnerabilities?
Welcome to the ScaleKit podcast. I'm Ravi, one of the co-founders of ScaleKit. ScaleKit is an auth stack for AI applications. Today, I'm thrilled to be joined by Liran, Director of Developer Advocacy at Snyk, where he's conducting cutting-edge security research for AI-generated code and agentic workflows. Liran, we are so excited to have you here.
Hey, Ravi. Thanks for having me and inviting me. This is really cool connecting on a similar kind of like security space here. You're doing a bunch of work there as well, so this is going to be fun.
Yeah. So, Liran, before we go to security and agentic workflows and AI applications, I want to understand your career journey of where you started as a developer and then move into developer advocacy. How did that pan out?
Oh, wow. Okay. There's a lot of history there, but I was a very early kind of like Linux user from back in the 90s. I used to have like run my own BBS dial-up modems, hosted some some conversations over analog medium in that sense. So I got into software very early age, then the army here, and then afterwards basically went into kind of like doing a lot of like system integration and even deeper in the rabbit hole of like make files and C and IP telephony, so very kind of like kernel embedded development, which was like very different things from what I was doing later. And then my career kind of like took a different change. It was like a 180 degrees change towards web. I enjoyed, kind of like, going on the web, security was something that I didn't really foresee or plan a career in security or the security space, but it was always since my early childhood, like something that I was within the circles of, if so to say. So got into web and then much into from PHP, those days were great. As much as you could say that for PHP, but from that point to like JavaScript and Node, early 2014, ecosystem blew up. Did a lot of like speaking, love sharing content, love doing open source. I started doing a lot of, I would say, like activities around like meetups and conferences. It wasn't really a developer advocate role. I was still like an engineer, but I love doing those things. And literally someone from Snyk, his name is Simon, is like an amazing person, just like tweeted at me, DM'd and said, hey, do you want to talk? And I was going on to this call and I was like, do you want to do all of this security, Node.js, open sourcey things as an actual job rather than a hobby? And I was like, let's see, that's it.
So, Liran, one of the things that I'm interested in, you spoke about being part of speaking and contributing to open source and being vocal both digitally and physically while you are an engineer. So one of the common stereotypes or common perceptions is engineers tend to be introverts. They just give them a laptop and just give them a problem to solve and they're great at it. But there is this general inhibition of getting in front of people and then speaking about the work that they have done. If there is one advice that you have for engineers to be more vocal and more outward toward the great work that they're doing and helping other people, what would that be?
I think what inspired me the most since I was early age was being inspired by others. Other people also inspired me to do stuff. And I think this is what I was like trying to also do, still do throughout like my day-to-day. That's kind of like the drivers. I think early on it was like doing a lot of open source. And sharing it and putting it out there so I could like share something. I grew up on kind of like that kind of mantra, but it obviously like resonated a lot within the team. So within the team, I'm 100% an introvert, but I enjoy like speaking with fellow geeks and like, geeking out on stuff and like sharing these, sharing like the tips and tricks between ourselves and stuff like that. So I think that's the thing that pushed me towards being, then like, a team lead and stuff like that, like inspiring, mentoring others, getting them, putting the spotlight on them to an extent and kind of like trying to get them to share more of what they know with others.
Yeah.
I think that's an important kind of like state of mind to be in.
I totally agree with you, Liran. I think one of the things I'm asking more and more engineers to do is, hey, you're producing great work, and there's a lot of opportunity for others to learn from the good work that you're doing. If you can be slightly more, vocal about the work that you're doing, either write some blogs, do some conversations, do some stage
Yeah.
shows, whatever it is, right? It's more about intentionally trying to help other engineers from your experiences,
Hmm.
not necessarily trying to do anything more than that. I think that
Yeah.
is something that I personally want to do more of, and I'm also advising more and more engineers to do. So one last question in this particular arc. Now you're kind of helping other developers understand security as part of your role at Snyk. How was that journey? Like how is your own journey of trying to teach others or trying to educate others or trying to bring that awareness of security first thinking for engineers who are writing application code? Because what I've observed is thinking of security while writing applications doesn't come naturally. So, how do you help developers inculcate that sort of thinking process about involving security first architectures or security first application design and application development as part of writing code?
Yeah. That's a really good struggle to kind of like have. That's like that's kind of like the mission here is trying to like make that change exactly. I don't think inherently developers like don't care about security, but more like they are overtasked with other things to do. So like like we talked about the full stack developer people, developers or outside engineers think yeah it's front end and back end, whereas it's like no, it's also like deploying. So you own the infra and you own performance and you own testing and you own accessibility and you own like a bunch of things. And security is just one of them. And I think the fact that mostly security is kind of invisible, whether for good and bad, whether you're doing something really well, no one sees it.
Yeah.
Whether something is like really bad, also no one sees it or knows it. So until something really happens, it's really kind of like hard to communicate like how important something is. And so I think that is the struggle. And I think developers once you kind of like weave it in with their workflows, once it's like a bit of a no-brainer, once there's like education part of it, that kind of like is what is helpful to drive a bit more kind of awareness mindset. And
Yeah.
I don't know, you'd be surprised, right? Because like I think to an extent when you talk to developers about security, they think more about what ScaleKit does rather than maybe what Snyk does. For example, like they think, oh yeah, security, yeah, I added authentication and then we have roles and permissions. Like, yeah, that's cool, but I'm talking about like, deep like code security stuff. Like, are you looking at, SQL injections? Are you doing the right things? There's like code security. Do you understand like taint analysis? There's like a bunch of like more technical aspects that I think they would probably do most of that. They would even say, yeah, I think I'm doing that. Or like they would rely on the framework, but they haven't really paid like attention to those, gritty details. And that's kind of like, that's the job. It's like inspiring them to think in these terms. I say there's 3 takeaways that I would give any developers. It's, user input number 1. Number 2 is user input. Number 3, user input. Do not trust user input at any case. And I
Yeah.
think we haven't even talked about AI yet, but I will kind of like drop the bomb and I would say it's not even user input at this stage. Now it's all the way to like LLM output and
Yeah.
what the model or agent says. There's like a whole different paradigm to get developers to think in that regard.
Yeah, so that was my next question. So when application developers are writing code, maybe you can teach them, hey, these are the best practices that you need to think of. One, this agentic IDEs or LLMs like Claude Code and
Yep.
Gemini Codex, etc. When they're writing code, does it make the developer's job with respect to security easier or harder? Aren't LLMs supposed to produce good code or secure code?
Yeah, I mean, I wish. I had a developer myself building stuff on the side. I kind of wish that would be true. But it's essentially like LLMs have been trained on a bunch of code that, me, you, a bunch of other developers written all over. And there's like a good amount of that that's not really like the most secure, performant, kind of like engineered to production code, right? So you're going to make mistakes. There's like so many. I could take this like so many different aspects and avenues. So, for example, if you are bringing an LLM, if you're bringing a coding agent to an existing code base, what happens? Like, what do you expect to happen if the code base is already riddled with vulnerabilities? The LLM kind of like studies the existing coding conventions. So if you're using, like I said before, like, you might have an SQL injection lying around just because you're basically using a bad practice of concatenating user input to the query. The LLM will kind of like learn that habit, that feature of, so to say, of how you code, and will just do the same thing, propose similar code. And so you basically amplify the amount of vulnerable code you have. And that's like legacy code bases. That's not even new greenfield stuff, which also there are like so many things to unpack there. I think to make that short as an answer, I think we want LLMs and agents to be producing secure code, but there's definitely there's still a journey to go there. And that's not like me hand waving. There are research articles that secure coding benchmarks that actually test out, and repeatedly they show that LLMs actually not only produce vulnerable code. One of the recent ones in March 5 this year was like a paper showing that 30% of JavaScript specific code that they benchmarked was like riddled with vulnerabilities. I was saying that in one of like my CDJS at London conferences. And I was like, yeah, so of course the genius in the room would say, let's tell the LLM to fix it. I mean, it found the vulnerability, maybe, let's tell it to fix it. I was like, yeah, that's what those academic researchers did. And they found that, also like there's like a very low percentage of fixable code by LLMs. So there's still a journey to be made, I think, here.
Yeah, like you said, it's also because of the code with which they are trained. It's not necessarily secure.
Yeah.
And while generating, they're using the same patterns. It's kind of the same proliferation that is happening based on what they're trained with. So it's a great point that you mentioned, where you said brilliant mind said, why don't LLMs fix that?
Yeah.
But I'm thinking there are now code review agents, for lack of a better word.
Mm-hmm.
Is there an opportunity where these code review agents can pick up vulnerabilities in the code and suggest alternatives? They're like mix of agents, code generator agents and code review agents working together to produce secure code.
I think that's an interesting approach, but mostly what happens, like commodity agents that we see, like coding agents that have like a slash command that says, hey, let's, security review this. Mostly what happens is under the hood, when you unpack what that actually does engineering wise, is literally there's like a big chunk of context, like a prompt that says, check for XSS, check for SSRF, check for this and that and whatever. And at the end of the day, that's just not enough. Like if that was enough, like everything was so simple, we would literally throw all the OWASP top 10, ASVS, the secure verification standards, everything at it and just tell it, just create secure software. You could throw a PRD at it, but you open the website, afterwards, like 30 minutes later, and you see the agent does like really weird things, and you hang up, just like, doing vibe coding and prompting it to do something else. So you understand that just like throwing a lot of like prompts and specs at it isn't the ideal. Plus, I think we're going into an economy where there's like a token economy where you want things to happen fast. You want them to be efficient. You want to run them locally. You don't want to like have context struts. You want to have like maybe specific agents, if so to say, that are specific. Like they get maybe a big amount of input, but they return a small amount of output for the other ranges to kind of consolidate. There's like a whole thing, I think, to unpack there. But I wish it was as easy, again, as like telling it, go ahead, generate secure codes. It's a production system. If not, I'll be fired. All of those kind of stressing it out. We've done these experiments on the YouTube channel, on Snyk YouTube channel for a long time. You could just go there and watch the experiments as we kind of stress the model into generating secure code. And I have a really good horror story on that one. But it doesn't always work. That's the real problem.
Yeah. So from the Snyk's point of view, are you adapting your SAST engines and DAST engines to figure out new vulnerabilities that these agentic IDEs or these code generation engines are actually introducing? How did that have to change your roadmap or your product, or what are some of the adaptations that you had to do?
Right. So, I think Snyk was kind of like a bit of ahead of the curve on this stance. Maybe 5 years ago, we bought a company, a Swiss-based company called Deepcode. They were building a symbolic AI-based engine. So you have the AI kind of like landmark there, but it wasn't like machine learning in terms of like neural networks and stuff like that. It was like really, as it's called, like, good old fashioned AI. You give it kind of like a rule system. It's like an expert system that goes and tries to apply some kind of like, obviously like learning and then inference out of it. but it would actually understand better how to apply some rules. And it was based on like the expertise of like, the Snyk security analysts to understand what the vulnerability is, how should it be detected, and what would be the fix. So we kind of like were ahead of the curve in terms of like we were AI powered. It wasn't something I think we can like, marketed. Really. I mean, today things are changing, but like it's something that it was a very powerful way of just doing that. And one of the advantages of doing that was symbolic AI is something you can easily rational, meaning you could ask the engine back and say, why did you find an XSS in this React code base? And you would see the exact pattern and flow, why that happened. If you try to ask an LLM, why did you think, year 2025 plus 5 years is 1400, it wouldn't really know to tell you, right? We have this problem with, these neural networks for pinpointing the exact, how did they get to a specific output with the neurons going around. It's not something we know how to do and why it works. So that's, I think, one of the advantages we had early on. And of course, now we kind of like weaved in. So like when you generate a fix with Snyk, we do use an LLM. We use a very, our own kind of like trained version of an LLM to generate that fix. But finding those vulnerabilities is still something we kind of like rely on a lot in terms of like our own, backend engines. And so I think we were very, to your question, very aligned on this, I would say, I don't call it revolution. It feels like this is like 3-4 years into it, but like everything has changed. It's like we're living in the future every day. Yeah. It's just incredidy. The symbolic AI engine too runs super fast. So I think we kind of like found ourselves where developers have a really, really, really good way to kind of like just leverage security analysis, because now when Gen AI generates code, like when the Copilot or Codex or whatever just generates code and like puts it on the open file or whatever, literally the moment that you save the file, like the Snyk code extension on VS Code or whatever, just runs, and under like seconds it goes and gives you the analysis in real time, which is one of like I think really, really, really the distinguishing kind of like, factors from Snyk to other companies where you can actually give that feedback. So we found ourselves like developers generate so much code in so little time, and we're able to like now catch all of that vulnerabilities. And I think that's like a really cool way of saying it.
It's very interesting. And I just want to understand, in the last couple of years, what kind of vulnerabilities have you seen rising because of the LLM generated code that maybe that your Snyk engines are catching more of, or what you're seeing online, so that developers actually, if they need to think of only 2-3 things, they should think about these vulnerabilities upfront whenever they're taking assistance from LLMs?
I don't think I have data to back this up yet. So so this is a bit of like a hunch in what I'm saying. So first off, let me take it like to that horror story I was mentioning before. So like I said, we have like this video series on the YouTube channel where we take model every time, like there's like, every day there's like a new model, we take it to a test ride, and we give it a very specific prompt all the time, the same prompt. So we can like benchmark it all the time. Nothing changed about it. It's essentially create me a simple to-do application in Node, make it secure. If not, I'll be fired. It's very, very important. This kind of like, 4 sentences prompt. When Claude Sonnet 3.7 was released, it feels ages ago, but I think it's literally like 3 or 4 months ago. What happened is we were like, yeah, let's take it to like a ride and give it the prompt and see what happens. And we like ran it, and it actually gave a very decent code base. We had like Helmet with Express, stuff like that, like no cookie issues, rate limiting, JWT stuff. Like it was kind of like okay. And I was and it had like a really good amount of validations on it as well. It was like Mongoose and MongoDB, and it has like a model. It has like a validation layer at like the middleware, and then on the model level and everything. And I was like reading the code. I was like reading each file. It wasn't that many files, but like 10 or 15. You could like scan through them in like a few minutes. I was like reading, and I was like, I was seeing a regex, and I was, I as a security researcher to an extent, recognizing a bunch of patterns already in advance. And I was like, okay, there's a regex here. What's up? Is it vulnerable? Could you like create a denial of service? Read those kind of like vulnerability there. And that's exactly what happened. So we have like a video on this and a paper on this. It's like, you literally like you would use the Sonnet 3.7. First thing it came out. It seems like very innocuous kind of like code. everything just works. It looks like super secure. But I have like a POC reproducing it where I could send a request. It was basically a regex on validating the email address. So if you would register to the system, you could register with an email address that is actually legitimate in terms of like the address. But on the validation level, specifically, it would pass like the middleware and everything else, and it would get stuck, hitting the CPU at like 100% for Node with that, really bad regex that Sonnet decided it was going to write. So here's one example. I didn't know that they are like so hungry for regexes. Like, seems like they use regexes for a bunch of things like string parsing and whatever. I've seen that with URLs as well. And I was like, no. Do new URL, use that. And if something is bad, it will throw an exception. It's like, I'm trying to steer it all the time to like do something else. So that's definitely something I've seen happening time and time again. And MCPs there's like an interesting avenue to explore there, because I feel like if we get to that, to talk about it, like the whole command injection thing, which used to be like something that was like, yeah, no, it's for a CLI tool, it's just running on locally or whatever. But no, not at all. Now those things are like remote code execution. There's no such thing as local anymore.
Yeah, I mean, it's actually great, right? So a couple of things that I took away from that is, so when a junior engineer looks at the code that is generated by LLM, it looks great because it has all the middlewares, it has all the validation, exactly. And you would be none the wiser. And the worst part, it lulls you to a sense of security, assuming that, hey, everything is great, there's nothing to worry about. But unless you put through a kind of rigorous, purposeful security testing, you wouldn't even realize the underlying issues. I think that is even worse than directly producing insecure code. I think that's a great example, Liran. Thank you so much. And because you spoke about MCP, I wanted to broach that topic too, right? I believe MCP as a spec is great. It came at a time when, hey, how do you build agentic workflows that can speak to third-party applications in a standardized manner? It's great. To build workflows that you don't have to upfront determine what needs to do as part of agentic AI applications. But when they first came out, they came out with SGDAO as a protocol. That means the MCP servers needs to be co-located with the agent that it is running on. I assumed it would have been a security nightmare. I want to understand if you have any experiences or stories that you want to share from that era.
Yeah, well, you're saying that era as if that was like dinosaurs. That's like 2 months ago, right?
Exactly.
It's pretty incredible the fast pace this goes. I mean, I love MCPs. I'm a big fan. I think I've seen them first like around March or April, and I was like getting really deep into those to an extent that I was like building vulnerable MCP servers, so I can actually test it out and test like the early like Snyk products with them. I don't know if I have a specific say on local versus remote. I think there's like some differences there, like remote you can't easily inspect versus local you are actually take. And I relate to what you're saying about, you are basically downloading something running locally on like the developer machine.
Yeah.
I get that. There's like, what are you installing? What's the licenses of this? What's the dependency? It's like there's a bunch of like an attacks kind of like a spacer, but also if you would go to like a bank or something like on the government and you tell them, hey, you have to like connect to this remote MCP servers, they will at that point immediately like stop you, said no, nothing gets out of our cloud or whatever. How do we know that you don't go through like the code and the changes and whatever gets sent to MCP remotes and stuff like that. So I think there's a bunch of trade-offs and differences between them. And obviously they come with some security kind of like pay that you have to like figure out. That said, I think, so here's the thing. What I've been doing recently with MCP is I've been creating a bunch of tools around detecting MCPs. So if you have locally running like MCP servers, and as you know, you can have them in like different files, like locally scoped to the project, to the user. They're like defined differently for like Claude and Cursor and VS Code. Like they're scattered around different, folders and files. And I found that very daunting. So what I did was like create this like LSMCP on like CLI. I was like, yeah, I want to know at any given time, like which MCPs I have configured and if they're running or not. And then I was like, hey, you know what? One vector of attack for MCPs is sometimes for the MCP to kind of function, depending on what it does, you kind of need to give it like an environment variable with like an API token or creds. I feel like we've like gone like, we went to the future and then adopted some best practices from like 20 years ago. You have like credentials lying around, and people are like, yeah, no, .env passwords are just fine. Well, not really. And so now this tool like detects your MCPs, but also says, yeah, this MCP has like a creds on disk, like plain text that could be exfiltrated. And we're talking about this, but like just literally like 4 or 5 days ago was like the Nix malware attack, which actually weaponized LLM and AI coding agents to do exactly this, like take all of your .env files and send them to like a public GitHub repo. Anyway, that's like there's a whole story again to like deep dive there, but there's a bunch of MCP security issues that I've been kind of like researching, going into what I've seen and reported on, like kind of like disclosed several vulnerabilities to some MCP projects, and they've been mostly command injection because MCP is kind of like just like pass some user input to the exec system call, whatever, and that's like insecure. And you expect the LLM to maybe just put that input correctly, but no, that doesn't happen. I'm sorry, that's a fantasy. And one thing I've actually just noticed that I saw, I think, a report from another company like disclosing this was SQL injections in a sort of like MCPs that give you like a read-only query, but that is implemented in an insecure way. So you could actually create a lot of like problems on the database side. If you can create, you could either do like a full-on SQL injection where you escape of the read-only type of like restriction and actually do writes. Another aspect of it is like you could actually do a denial of service on the database if you still have just read-only by calling like internal methods that PostgreSQL has, and like calling shutdown, calling sleep, a bunch of things like that. So there's an interesting space on code security vulnerabilities that are now very specific to MCP that you could like make some mistakes on.
Yeah, I totally agree with you, Liran. There are a couple of points that you mentioned where local SDA MCP servers versus remote MCP servers. Again, at ScaleKit, we have a strong hypothesis that most of the MCP servers will become remote. Like they're less than maybe 10-20% of overall MCP servers that are remote HTTP based. But we believe that with the latest changes in the spec about the authorization standardization, remote MCP servers and all that, because we think it is much safer and have better control over remote HTTP servers than asking your customers or your employees to download an executable on their machine and asking them to add environment variables with their credentials. Like you said, like we are living in 2025, not in late 90s or early 2000s, where the credential exfiltration is easier to do when you are having them lying around in some TXT files that anyone can read through.
No, Ravi, 100% agree. I think that's kind of like, that's a good direction to go for. I think there's like a really good consolidation towards like MCP gateways or proxies to an extent as well to like help organize things, because I think one of the issues for big IT companies, maybe not startups who want to run fast and maybe sacrifice some security risk. But enterprises and big companies have the problem of like shadow IT, shadow LLM, shadow AI kind of things, where devs just like go off and install a bunch of things, install tools, install MCPs, and IT has no idea what's going on. Security doesn't really know what is where. So I agree with you, Roy. I think remote helps add a bit of security control. Maybe you have to like accept the fact that it goes to the cloud. Maybe you could have like, some other version of that, but I agree that's kind of like...
Yeah, I think it's a great point that you mentioned where IT team or the security team are none the wiser about which MCP servers their employees are using in their laptops, right? And which API guys they're throwing them around in their text files, right? It doesn't really help. And having a central control plane for IT teams to observe what their employees are doing or which MCP servers that they're using, whether they're supposed to use them or not, I think that is going to kind of go to the next level of actually democratizing MCP server usage across organizations. And I believe having remote MCP servers is better to do than HDA-based local MCP servers. I know that you spoke about some of the vulnerabilities that you detected. I also want to understand, how is Snyk as a platform thinking about creating security layer and protecting MCP servers that are being built? Do you see them differently, or do you see that as, hey, they're just another web applications that are following different set of HTTP protocol schema? What is your thesis and point of view on that?
So I think very deeply, like Snyk understands that the future is with AI, but developers and companies, like they will refuse as much as they can, right? They can't always like cope with like, rogue like developers and stuff like that. But like you have to trust AI at the end of the day. You have to, like you said, we opened this, right? Like we said, the LLM generates code. Do I trust it to literally now do git commit and add that file and push it to the repo? Do I trust it or do I not? Is there like a register or is there not? So I think that's like the deep rooted kind of like belief that Snyk has, that you have to like trust AI. And that's what we're trying to build. That's kind of like with MCPs, I think there's like several ways of that. So first off, you have like the AI driven kind of like workflows where you would have like, well, Gen AI, but like maybe taking it more like AI native applications where you actually use something like, Claude Code or stuff like that, which is great. But you pair it with something like the Snyk MCP server, and then where the agent creates code. Once it's finished, it saves the file. It will go and run the Snyk code analysis. And I have like a really cool demo where there's like an actual ping pong between the coding agent to Snyk MCP, because like the coding agent says, no, I'll implement the fetch URLs this way. And Snyk scans it's like, no, there's an SSRF there. And so the agent does, okay, I'll try something else. And it does, and then goes, and then, it knows to obey the rules. It needs to like scan it again. And Snyk scans it, says, no, that's still insecure. It's like, go like 6, 4, 5 times until it actually gets it right. So the Snyk MCP server, I think, enables those coding, like going fast. And that's kind of what we think about as like secure at inception. We want you to be able to like utilize agentic workflows and AI and coding tools like that. And when you generate code, it has to be secure at the point where you generate it. And that's kind of like the root of it. And it goes back to, choosing dependencies, which Snyk started with, your security inception started with like dependencies, about the 10 years ago. Now it's the code through like LLMs or ChatGPT or whatever you use. That is one aspect of it. That's like the Snyk MCP server gives you that secure at inception. Now, there's another aspect of MCP that Snyk says, which is the MCP servers themselves. We haven't talked about this much. MCP servers, like you said, they are generally one, especially if you install them as like CDIOs, like command one-offs. Who knows? Like they could be malicious. They could have a bunch of like different kind of attacks, like shadowing tools and tool poisoning and malicious prompts in them. And they would actually can use like, like bad licenses or like bad dependencies in the MCP servers or whatever. There's like a bunch of like different things that can go wrong. So for that, Snyk actually helps secure the MCPs themselves, not just the code inside them, which is what we've done also until now. But I think the new thing is also making sure that you don't have those like indirect prompt injection within the MCP tools. If you're like using some, MCP that you don't know if you're trusting exactly or not, or if it changes under the hood or not. So we definitely do that. And that's actually an open source project from a company that Snyk acquired just recently. So it's called MCP Scan, and you can scan on this kind of like MCP server. There is a very interesting research I would recommend everyone to read. It's called, if you just like Google toxic flow analysis for MCPs, that's going to show you an attack that we reconstructed on top of GitHub of how like indirect prompt injection could kind of like, poison you to an extent and like steal files and stuff like that. So I don't know, like you have to read it to like really make it click. There's like several steps to this, but there is definitely like a wide array of MCP security topics that we are tackling at Snyk.
It's interesting, Liran. I really loved how you are actually helping the LLMs generate safer model by leveraging Snyk's MCP server at the time of code generation itself, so that the code generation itself is much safer than doing another security analysis at a later point of time.
Yeah.
I think that approach is really, really interesting. There are developers building MCP servers, and there are a lot of developers who are building MCP servers. What are top 2 to 3 suggestions or advice you have for them while they're writing code for their MCP servers? From the security point of view, from maybe performance point of view, how do they protect themselves from all the bad things that can happen from their MCP servers?
So I would say, this is like we're trusting the MCP server. So I'm not going to talk about like malicious things that can happen since it's like people developing their own. I would say there are 2 things. Just as you write any code, what you really want to do is make sure that there's like MCP server code, like the tool implementation, the resources, the prompts. All of that is not something that would be in some way like injected via direct or indirect prompt injection. So you have to like do secure coding conventions. This is like classic Snyk doing, static security scanning on the code of the MCP server itself. Then there's like the layer of like the dependencies and the licenses, like again, classic dependency for any application you want to scan and make sure that nothing there happens. I think it's a good idea to add auth and make sure that you have like, authentication and authorization in place, roles and permissions. All of that is like super important. Ensure that you don't have like, any kind of like leakage and stuff like that. Think about that in advance, because the last thing you want to have is like creds lying around on like .env for like the mcp.json like env variable thing happening and like that. I think if you end up building an MCP server like that, you may get, people asking you why that's happening. So you kind of like need to figure out like the authentication part in advance, so you don't have like the late refactoring nights of like then making it right. So I think those are like very easy pillar cases to get started with, and Snyk scans for a bunch of days, so you can use that to code secure MCPs as well.
Yeah, I think that's a great advice. There are a couple of things that you spoke about. One is common for not any application developer, not necessarily MCP server. All the good practices that people need to think of when they're building application, like the user input, like you spoke about multiple times earlier in the conversation, and ensuring that they're using the right dependencies and those underlying dependencies are not causing vulnerabilities. And of course, authentication and authorization to make sure that only the trusted MCP clients are talking to the MCP server. This is great, Liran. As one last question, I want to go back to your roots. If there are developers, there are engineers who want to transition to the developer advocacy, what sort of career advice do you have for them?
Build things and share them. So you have GitHub, you have code. There's like not many excuses to like not build things these days, and then share them on X, Twitter, Blue Sky, meetups, conferences, whatever you want. Like join some favorite language ecosystem user group and show it around, showcase it. I think you'll end up finding many new friends and connections by doing that.
Yeah, that's great advice. Thank you so much, Liran. Thank you so much for taking time and then talking to us about security in MCP servers and agentic workflows. And thank you so much for sharing your story from developer to developer advocacy. It's been great talking to you. Thank you so much for coming on the show.
Same. Thank you.
Thanks. Have a good day.